Hi students, in my last explanation I was teaching you the efficiency of the Carnot cycle for the same problem. So which you are seeing on the screen. For the same problem we have seen how to find out the efficiency of Carnot cycle. But in this video, so I am going to teach you how to find out the efficiency of the Rankine cycle. So I'll take the same data for both the problems, and so same 17.5 bar as a P1 pressure and the same 0.75 bar as a P2 pressure. So for these two different pressures, how to find out the Rankine cycle? So now what you're seeing on the screen is the TS diagram for Carnot cycle. So next we are going to, I'll take you to the Rankine cycle. So this is the Rankine cycle TS diagram, right? So TS diagram and even HS diagram, that is enthalpy and entropy. TS means temperature and entropy, and HS means enthalpy and entropy. So these two diagrams, so you need to draw in the examination, so to get full marks. So let us see how the Rankine cycle is drawn in the two different diagrams like TS and HS diagram. If you see 1S, 2 is the heat added in the boiler. So he is nothing but it is taken as 1S, or you can take any proportion, like you can take as 1, no problem, not an issue. So they have taken it as 1S, 1S into 2, 1S to 2, and 2 to 3S, 3S into 4. Why they have taken S is because it is in the dry saturated, or so different conditions will be there. Now this is dry saturated second point. Sometimes it will be wet steam, sometimes at second point will be superheated steam. So different terminologies will come. So not an issue, you can draw 1 2 3 4, so like that. And 1 to 2 is boiler work, that is heat added in the boiler. And 2 to 3 is nothing but your turbine work. And 3 to 4 is condenser work, and 4 to 1 is pump work. So pump work, that is nothing, that is 4 to 1 is pump, right? If coming to the PHS diagram, so 2 3 process is isentropic, and 1 to 4 is isentropic again. Okay, so now you need, already we have seen that efficiency of Rankine cycle in my derivation, that first video in module 3 vapor power cycles. So I have taught you how to derive the efficiency of Rankine cycle. So finally what you got was WT minus WP divided by QH. WT means turbine work. Where do we get this turbine? 2 to 3 is turbine. WP is pump work. Where do we get this pump? It is between 1 to 4, right? And where do we get this QH? That is heat supplied. Where do we supply heat? During 1 to 2 process. So there you supply heat. So that is nothing but heat addition. So WT minus WP divided by QH is equal to H2 minus H3 minus of H1 minus H4 divided by H2 minus H1. You should know these terminologies. Turbine work is equal to H2 minus H3. Pump work is H1 minus H4. And heat added is H2 minus H1. Okay, so this is the formula for Rankine cycle. Now let us go to the other slide. So just see here, since the change in volume of saturated liquid water during compression from state 4 to state 1 is very small, V4 may be taken as constant in a steady flow process. So what is here is in the previous one, if you see 1 and 4, these both are very small and this value is neglected. So what we see here is, right, this value is neglected, and so because of that very small work, so we are not going to take into consideration for our problem. So work done is equal to W is equal to minus V into dP. So here you should know why it is taken as negative sign, minus V into integral dP. Why? Because pump we are doing work, because turbine it is a positive work and pump is a negative work, because we are doing work to the system, that is why it is taken as negative. So W is equal to minus V into integral of dP. So WP is equal to H into H1 minus H4. If you take a H1, that is also fine, not an issue. So H1 or H1S, why they have taken it as H1S? Because um, so HS, so if you go back to the previous one, like here, if you see HF, HFG, HG, right, and this is for 17 bar and 18 bar. So HF, HFG, HG, this kind of values will be there. So that is why they have taken it as HS, HS1, H1S, right. If we come back to this one, H1S value is taken as 0.001037 into 17. Here, if you look at it, WP is equal to H1S minus H4. That is equal to VFP2 into P1 minus P2. Why they have taken this VFP2 into P1 minus P2 is the previous line W is equal to minus V into integral dP. That V stands for VF. Where do we get this VF? In the P2 pressure. So if you go back to the P2 pressure here, so this is the P2 pressure, the which is so see, last line you can say similarly HF, HFG, HG, SF, SFG, SG. Actually, truly speaking, one more value has to be taken here, VF. If you take VF volume, so that also to be included, it should be the value of VF will be 0.001037. So that value has to be substituted. That value will be taken from steam table book. So into 17.5 bar P1 pressure minus 0.75, that is P2 pressure, into 10 to the power of 5. We are converting from kilonewton per meter square, bar into kilonewton meter square, that is 10 to the power of 5 into 1 divided by 1000. So it will become 1.737 kilojoules per kg. All right. So H1S. So we don't know what is H1S because we know pump work WP, we know H4 value, but we don't know H1S. So H1S is equal to 1.737 plus 384. H4 value is 384. Where do we get this H4? We have already found out in the previous one, right? So H4 is equal to, here you will find out H4. H4 means, if you go back to the figure, H4 is you come across here. So once again, Rankine cycle. So you will get H4 is HF, HF of P2. So if you look at the TS diagram, where do we come across this fourth line, HF? That is liquid region. So which pressure it is? P2 pressure. So P2 pressure, what is the HF? We need to find out. So P2 pressure, what is the, this is the P2 pressure, and what is the HF? 384.25. You can see that one, HF is equal to 384.25. So that value should be taken here because that is a wet region. So here you have to substitute 384.25 plus 1.73. You will get H1S, or H1 also you can consider it, 385.99 kilojoules per kg. So hence turbine work WT is equal to H2 minus H3. Already we have found out that value. H2 minus H3 is equal to 522.47 kilojoules per kg. Next one is heat supplied. Heat supplied, how do we find? Again, we'll go back to the figure. Heat supplied, where do we come across this heat supplied? 1 to 2 process. 1 to 2 is the boiler one. That is the place where heat is supplied. So H2 minus H1 will give you the heat supplied. So here, dear students, here a small correction should be made. H2, in the place of H2, 2.794.1 is, that is wrong actually. It is 2794.1. You can correct it while you solve the problem. It is 2794.1, and H1S, just now we have found out it is 2408.11. So H1S, so that value if you put So 2794.1 minus 385.99 is equal to 2408.11 kilojoules per kg. So this is how you'll find out the turbine work and what is the heat supplied. Next thing is we need to find out um, heat supplied, both values are known, like what we have seen the previous one, same thing is there. So next one is efficiency of Rankine cycle. Efficiency of Rankine cycle, already we know that formula. So we can take this one also, H2 minus H3. Otherwise we can take H2 minus H1, H2 minus H1, H2 minus H1, numerator denominator gets cancelled. So what you will get here is, so H3 minus H4. So same thing if you substitute here, so you will get 99.6, 0.9967 is the work ratio. RW is equal to 0.9967. So this is how you will find the work ratio. All right. So this is, so the Carnot cycle is different and Rankine cycle is different. So same problem can be applicable for both Carnot and Rankine cycle. So you need to draw this TS and HS diagram for solving this numerical. Thank you.